What you're about to see powers the modern world. Every second, thousands of liters of fuel are burned across the planet. Cars moving, planes flying, industries running. And behind all of it is one of the most powerful and complex systems ever built. The oil refinery. This isn't just a factory. It's a transformation machine that turns raw, useless crude oil into the energy that drives civilization. So how does it actually work? Crude oil starts its journey deep underground, formed over millions of years from ancient organic matter. When it's extracted, what comes out isn't clean fuel, it's a thick, black, chaotic mixture of hydrocarbons. On its own, it's almost useless. To unlock its value, it has to go through a refinery. The moment crude oil arrives, whether through pipelines stretching thousands of miles or massive tanker ships, it enters a facility that never sleeps. Refineries operate 24 hours a day under extreme temperatures and pressures controlled by highly advanced systems and skilled engineers. The first step is separation. And this is where things get intense. Crude oil is pumped into a furnace and heated to around 400 degrees Celsius. At this temperature, it doesn't just heat up, it begins to break into vapor. This vapor is then forced into a towering structure called a distillation column. Inside this column, a precise temperature gradient exists. Hot at the bottom, cooler at the top. As the vapor rises, it begins to separate based on boiling points. This is where chemistry becomes engineering. The lightest molecules, like propane and butane, shoot straight to the top. Slightly heavier ones condense into gasoline. Below that, kerosene forms, which will eventually power jet engines. Then comes diesel, essential for heavy transport and industry. At the bottom, the heaviest, thickest substances remain, materials like bitumen, used for roads and construction. At this stage, the crude oil has been separated, but not optimized. Here's the problem. Natural crude oil doesn't produce enough high-demand fuels like gasoline. And that's where refineries become even more advanced. They don't just separate, they rebuild. Through a process called cracking, massive hydrocarbon molecules are literally broken apart. Using extreme heat, pressure, and specialized catalysts, these heavy molecules are forced to split into smaller, more valuable ones. This is controlled destruction, engineered at the molecular level. At this stage, the crude oil has been separated, but not optimized. Here's the problem. Natural crude oil doesn't produce enough high-demand fuels like gasoline, and that's where refineries become even more advanced. They don't just separate, they rebuild. Through a process called cracking, massive hydrocarbon molecules are literally broken apart. Using extreme heat, pressure, and specialized catalysts, these heavy molecules are forced to split into smaller, more valuable ones. This is controlled destruction, engineered at the molecular level. Then comes reforming. This process doesn't break molecules, it reshapes them. By rearranging their structure, refineries create fuels that burn more efficiently. This directly increases the octane rating of gasoline, making engines more powerful and reliable. But raw fuel still isn't clean enough. Crude oil naturally contains impurities, especially sulfur. If left untreated, this would lead to severe air pollution and engine damage. So refineries use advanced treatment processes to remove these contaminants. This step is not optional, it's critical. Modern environmental regulations demand ultra-clean fuels. That means sulfur levels must be reduced to near zero. Achieving this requires hydrogen treatment, chemical reactions, and precise control systems. Only after all these stages, separation, cracking, reforming, and treating, does crude oil finally become usable. And the result? A single barrel of crude oil can produce gasoline for cars, diesel for trucks, jet fuel for aircraft, heating oil, lubricants, and even the raw materials used to manufacture plastics, chemicals, and synthetic fibers. Everything from your phone to your clothes is connected to this process. Now let's talk about the scale, because this is where it becomes almost unbelievable. Building an oil refinery is not just expensive, it's one of the most capital-intensive projects on Earth. A small refinery can cost between $1 to $3 billion, but large, complex refineries? They can easily exceed $10 billion and in some cases go beyond $20 billion.
Why so expensive? Because every part of the system must handle extreme conditions, high heat, high pressure, and highly flammable materials. The infrastructure includes massive steel towers, kilometers of pipelines, advanced control rooms, safety systems, and environmental protection technologies, and that's just construction. Running a refinery is another challenge entirely. It consumes enormous amounts of energy, requires constant monitoring, and demands a highly skilled workforce. Engineers, chemists, technicians, hundreds of professionals working in coordination. Maintenance alone costs millions. And then there's regulation. Governments enforce strict environmental and safety standards. Refineries must continuously upgrade systems to reduce emissions, prevent leaks, and ensure operational safety. Despite all this, the industry remains one of the most powerful in the world. Every single day, millions of barrels of crude oil are refined globally. Entire economies depend on it. Transportation, manufacturing, logistics, none of it works without refined fuel. But the future is shifting. With the rise of electric vehicles and renewable energy, the oil industry is under pressure to evolve. Some refineries are already adapting, integrating biofuels, improving efficiency, and investing in cleaner technologies. Still, the reality is clear. Right now, oil refineries remain the backbone of modern civilization. They are the invisible engines behind everything we use, from the fuel in your car to the materials in your home. So the next time you see a gas station or board a plane, understand this. What you're using isn't just fuel, it's the result of one of the most complex, powerful, and precisely engineered processes ever created by humans. And it all started as crude oil buried deep beneath the earth. This is how oil refineries really work.